Hi students, here's a question from your homework from the e-text 619, which I suggested that you do right at the beginning of every week. I'm going to do this question because some students have been asking me how to use Excel and how to use the table. So again, this is chapter 6. This is not the central limit theorem. This is not a sampling mean. So it's just one single random selection. So here's the question. F&G Industries manufactures a motor that is marketed with a warranty that guarantees it will be replaced free of charge if it fails within the first 13,000 hours of operation. On average, F&G motors operate for 15,000 hours and a standard deviation of 1250 hours before it fails. The number of operating hours is approximately normally distributed, which is important. Part A, what is the probability the motor will have to be replaced free of charge? So we're going to do this both with table and also with Excel. So this is the situation. We have 15,000 hours, which is the average. 1250 is the standard deviation. You're asked to find what's the probability that they will have to replace a motor. So I know that 13,000 is left of 15,000, so it's there. I'm actually looking for this part since anything less than 13,000 hours will be replaced. Okay, so I do need to find this green area. So what I do is I standardize this. So the standard normal curve will mean that the mean is 0 and Z is something which we have to find out. Okay. So Z equals 13,000 minus 15,000 over 1250. And that works out to minus 1.6 standard deviations, right? So I'll replace this here with minus 1.6. So I know that now. So we're going to do this both with the standard normal curve and also with so if we look at our Excel table, our standard normal table, we know already that the standard normal table that we have gives you the area from the standardized area from 0 to the right. It doesn't matter if it's negative because it's symmetrical, right? It's symmetrical, which means that both sides will be the same on either side of the 0. Okay. So let's pretend, so for the diagram here gives you a sample of what's happening here. So if Z's 1.25, it gives you this area from the 0 to the right, and that's all it's telling you. So what we're looking for is minus 1.6, which is here, right? But it's the same. It's going to be the same as pretend this is positive 1.6. It's going to be the same as there. So we look up 1.60 right, from here to here, and we notice that it's where's that? We notice that it's 0.4452. So if that is 0.4452, then that is also 0.4452. So that's what we need. So let's go back. So I know that this is 0.4452, right? And these are equivalent. So I need to find what this is. So that's easy enough. I know that half of this curve is 50%, just like half of this other side is 50%, right? So because the entire curve is 100%. So we know that the probability that x is less than 13,000 is exactly the same as the probability that the Z score is less than minus 1.6. And I know that to find the green part here, which is what we're looking for, is going to be 0.50, half of the curve, 50%, minus what we don't want, which is that 0.4452, and that gives me 0.0548 or 5.48% if you want it in percent. Okay, so I know that's 5.48%. And that's how you do that. So let's do this with Excel then. So we'll do it in here. Okay. So Excel gives you the area differently than the table gives you. So what Excel does is it does this, cordon that off. It gives you the area from the far left tail all the way up this way. So if you put in 0, it's going to give you 50%. If you put in 3.99 or 3.09, it's going to give you about 99.99% or almost 100%, right? So it starts from the left tail and rolls to the right, and that's what that does. So in this case, Excel will be easier because we start at the left tail and we want up to minus 1.6. So to do that, we type equals NORM dot S, right, dot dist bracket. We put in the z-score minus 1.6, comma, and we always put in 1 because 1 means it's cumulative. It adds up all of the areas all the way up to there. And we press enter, and you see that the answer is 0.0548, which is what we calculated using the table. All right. By the way, Excel also has a function to figure out the standardized z-score automatically for you if you don't want to calculate using the formula. So I'll just quickly show you that. Equals norm, but not dot S. Dot S means standardized. Dot dist bracket. X is the thing you're looking for, so 13,000, comma, the mean, 15,000, right? The standard deviation, comma, 1250, all right? Comma, and do you want it to be cumulative? Yes. Oh, sorry, I should not have put commas in for 13,000. There we go. 13,000, 15,000, 1250, and 1. Don't put commas in when you're putting in large numbers because we separate things in our functions with commas. 0.0548 gives you the same. So if you use the formula to calculate the z-scores, then just use .s. If you don't, then you can just use norm.dist or just use the table. Let's do part B, which says what percentage will have to be replaced. Oh, sorry, what percentage of motors can be expected to operate for more than 17,500 hours. So again, we draw this. The mean is 15,000, the standard deviation is 1250, 17,500 is to the right of this. And we want to see what percentage of the motors can be expected to operate for more than 1750 hours. So we're looking for this part here, right? The green part. Again, we find what the equivalent standardized scores are. I know that for the mean it's going to be 0. So Z in this case for 1750, right, will be 17,500 minus 15,000 over 1250. So the Z in this case will equal exactly 2.0. 2.0 standard deviations, which is matched with that. Okay, so again, with the table, we do this. Again, the table only gives you the right-hand side, so pretend this is 2.0. So the 2.0, you look up, 2.004772, right? So I know that this is 0.4772. I'm not looking for that part, I'm looking for that part. So let's go back to here. I know that this is 0.4772 because the table only gives you the area from the mean upwards. So I'm looking for the green part. So the probability that x is greater than 17,500 is the same as the probability that z is greater than 2.0 standard deviations. And in this case, it's 50%, the entire half the curve, minus 0.4772 and 0.0228. Or 2.28%, right? And that's what you're looking for. If we use Excel, then we have to do this. First of all, we find the area, the yellow area, all the way from here to here, because that's what Excel gives you. From the left tail, rolling to the right. It gives you the entire yellow area here, right? But we're not looking for that, so we have to do it in a two-step process. Equals norm.s.dist, right, up to 2.0 standard deviations, comma 1 cumulative, or you can type true, and I know that's 0.9772. All right, so this entire area, this yellow area here, is 0.9772, but I don't want that area, so it's equal to 1 minus, why is it 1? Because the entire curve is 1, minus that, and you see it's 0.0228, which is what we computed with the table. So again, that's the table, and that's also Excel. Part C, if F&G wants to design a motor so that no more than 1% are replaced free of charge, what would the average hours of operation before failure have to be if the standard deviation is 1250 hours? Okay, so the key here is average hours, not this the exact hour. So the average hours. So we draw our little diagram. I know that's 15,000. 1250 is equal to sigma, right? So no more than 1% are replaced free of charge. If no more than 1% is replaced free of charge, then it must be down here, right? 1%. And I'll shade it in, that 1%. If that's 1%, then I know that this is 0.49 or 49%, right? So what I'm looking for is the average that will make this happen, all right? So in other words, this average will have to change to make that happen. So I'm going to erase that that mean there, and I know that again the standard deviation is 1250. So we're going to do it both ways. We're going to look for the table, which will give us 1%. So here's the table again. So I'm looking for down here 1%, which means that in here it's 49%. So we have to use this part because the table only gives you that part. So 49%, the closest we can find, if we look, is let's see, 49, 2.33. All right, that's the closest you can come to 49%. 4898 is too far. 4904 is too far. So the closest you can come is 49.01. So we're going to use 2.33, but actually it's going to be negative 2.33. All right, because it's on the left side. Let's go back. So I know that this is a z-score of minus 2.33, right? I know that this is going to be 0. I need to find out what the average is, so mu is what we're looking for because it's asking for average hours. So we fill this in. So we start this, which I know to be failure to be 13,000, right? We want it to be 13,000, right? The first 13,000 hours. So what we don't know is actually this. Okay, so we know that x equals 13,000, z, the matching z-score is minus 2.33, the mean is 0 standardized, so we're looking for mu. So our formula is this, it's z equals x minus mu over sigma. So I know z, minus 2.33. I know x, it should be 13,000 because that's when you start replacing the motors. I don't know the average, what it should be. So divide that by 1250. I need to solve this, so I just cross multiply and solve. So it's going to be minus 2.33 times 1250, right? Minus 13,000 and change the sign. So mu is equal to 15,000. 912 hours, 0.5. So about 15,913 hours or 15,912 hours, 12 and a half hours is what the average should be to make no more than 1%. And that's how you do that. To use Excel, this is what we do. So we're looking for the standardized z-score. That matches up with 13,000. So we type equals norm and we select inverse dot standardized dot s dot inverse. So we click on that. We see that it's asking you to enter the probability. We know the probability rolls in from the left tail up to the right. So 0.01 is 1%. That's all you need to put in. It tells you that the standardized score is minus 2.326. We round it to minus 2.33 because our because if we want to match the answer to our table is only 2 decimal places. So minus 2.33, and that's the way you have to do it using Excel. Again, you don't have to use Excel. You can use just the table, which is, in my opinion, just as easy.